professor at LG Institute of Engineering and Technology. Today we are going to discuss a new chapter, that is vector calculus. Okay, so let's begin with the first topic, that is gradient. Now, the vector differential operator del is defined as del is equal to del by del x of I plus del by del y of j plus del by del z of k. Okay, we will define a differential operator del in this way. Okay, now the gradient of a scalar field phi is denoted by grade phi. Okay, so the gradient is denoted by grade phi and is defined as grade phi equals to, we can also denote it as del phi. Okay, and this is del phi by del xi plus del phi by del yj plus del phi by del zk. Okay, so we have this del operator, and what we are doing, we are multiplying it with a scalar field phi. Okay, so just multiply phi over here, so you will get grade phi as del phi by del xi plus del phi by del yj plus del phi by del zk. Okay, this is a vector quantity. Okay, so this is the formula to find gradient. Okay, so you have to remember this formula, and answer will be your a vector quantity. Okay, now let's begin with one example. If phi is equal to x, y, z is given, okay, then find the value of mod of grade phi at this particular point. Okay, so here phi is given, that is x, y and z. Okay, so we have to first find grade phi. Okay, so grade phi is what? Del phi by del xi plus del phi by del yj plus del phi by del zk. Okay, so this is the formula to find gradient. Now what we have to do, just find the derivative of this phi with respect to x, keeping phi and z constant. Okay, so derivative is yz. Okay, so yzi plus, now derivative with respect to y. Okay, so this is xzj plus derivative with respect to z, this is xy. Okay, so xyk. Now we have to find gradient at this particular point 1, 2, minus 1. Okay, so grade phi at 1, 2, minus 1 is equals to what? Now in place of x we will substitute 1, in place of y 2, and in place of z minus 1. Okay, so here we have 2 into minus 1i plus x is 1 and z is minus 1, so 1 into minus 1j plus 1 into 2k. Okay, just simplify this. So minus 2i minus j plus 2k, this is your gradient at this particular point. Okay, now the question is asked that we have to find mod of grade phi. Okay, so whenever we have to find a mod of grade phi, what we will do, it is like this, under root this minus 2, okay, is square, so minus 2 square plus this minus 1, so minus 1 square plus 2 square. Okay, just simplify this, so this is under root 4 plus 1 plus 4. Okay, so under root 9, and the answer is 3. So the method to find gradient is very easy. Okay, what we have to do, we have to just find derivative with respect to x, y and z and find this. Okay, if a particular point is given, then we have to find at that particular point. Okay, and if it is asked that we have to find mod, so in this way we can find its mod also. Okay, now let's begin with the next example. So the question is, if phi is equal to 3x square y minus y cube z square, then find grade phi at 1 minus 2 minus 1. Okay, this is phi function is given, that is 3x square y minus y cube z square. Okay, and we have to find grade phi. So firstly we will write the definition. So this is del phi by del xi plus del phi by del yj plus del phi by del zk. Okay, this is the formula. Now just find the derivative. So derivative with respect to x. So derivative of x square is 2x. So here we will get 6xy. Okay, here we don't have x, so its derivative is 0. So just I plus Now we have to find derivative with respect to y. So from this we will get 3x square, okay, 3x square minus, from this we will get 3y square, okay. So this is 3y square z square, alright, and j cap as it is, plus now del phi by del z means derivative of phi with respect to z. Now in this term we don't have z, so its derivative is 0. From here we have 2z, so this is minus y cube z, and here 2z, okay, so here we have 2, so minus 2y cube z k cap. This is the derivative, okay. Now we have to find gradient at this particular point, okay. So grade phi at this particular point, that is 1 minus 2 minus 1. So in place of x we'll substitute 1, in place of y minus 2, in place of z minus 1. So if 6 into 1 into minus 2 I plus 3, x square means 1, okay, minus 3 y square means 4, okay, and z square means 1, and this j cap plus minus 2 into what, y cube, okay, so this is y, so its cube means minus 8, okay, and z is minus 1, so here we have minus 1 k. All right, now just simplify this. So this is minus 12i, okay, plus 3 minus 12j, okay, plus, now see, we have 3 minus, so here we have minus 16k. Simplify further, so minus 12i minus 9j minus 16k is the answer, okay. So in this way we can find the gradient of a given function. Now, let's solve one more example. If phi is given log x square plus y square plus z square, then we have to find gradient of phi at 1, 0, minus 2. Okay, so here phi is given log x square plus y square plus z square. Okay, firstly write down the formula to find grade phi. So it is del phi by del xi plus del phi by del yj plus del phi by del z k. Okay, now just find derivative with respect to x. Okay, so derivative of log x square plus y square plus z square is 1 upon x square plus y square plus z square, and derivative of this bracket with respect to x is 2x. So here we have 2xi. Okay, similarly what we have here, 2y upon x square plus y square plus z square j, and 2z upon x square plus y square plus z square k. Okay, now we have to find grade phi at this particular point 1, 0, minus 2. Okay, so in place of x we have to substitute 1, in place of y 0, and in place of z minus 2. So what you will get here, 2 upon x square means 1, y square is 0, and z square is 4. Okay, I cap, plus here y is 0. Okay, so this whole term is 0, so 0j plus 2 into minus 2 upon 1 plus 0 plus 4 k cap. Just simplify this. Okay, so 2 upon 5 I cap plus 0 j cap minus 4 upon 5 k cap. Okay, so this is the answer of a gradient of phi at this particular point 1, 0, minus 2, right? Now we'll solve one more example. The question is, find a unit vector normal to the surface this, okay, at the point 1, 2, minus 1. So whenever we have to find a unit vector normal to the surface, so it is given by the formula n cap, this is n, okay, n cap is equal to gradient of phi upon its magnitude. Okay, so this is the formula to find unit vector normal. Okay, now here phi is given, that is x cube plus y cube plus 3xyz minus 3. We can bring this 3 over here. Okay, now first we will find grade phi. Okay, so what is the formula? Del phi by del xi plus del phi by del yj plus del phi by del zk. Okay, it is important to write formula every time. Now first we will find derivative with respect to x. So from here we will get 3x square, okay, this is 0. From here we will get 3yz, okay, so plus 3yz I cap plus, now we have to find derivative with respect to y, so we will get 3y square plus, from here we'll get 3xz j, okay, plus now derivative with respect to z, so we will get 3xy k. All right, now we have to find this gradient at particular point 1 2 minus 1, okay, so grade phi at this point, that is 1 2 minus 1. So in place of x we'll substitute 1, so here we have 3 plus, now here 3 into y is 2, z is minus 1, okay, I cap plus 3 y square is what, here 4, okay, so 4 plus 3 into x is 1, okay, and z is minus 1, j cap plus 3 into 1 and y is 2, k. This is your substitution. Now just simplify this, so 3 minus 6 I cap, okay, plus here 12 minus 3 j, okay, plus 6k. Now simplify this, so minus 3i plus 9j and 6k, okay, so this is your gradient at this particular point. Now we have to find its magnitude, so grade phi at 1 2 minus 1, and we have to find its magnitude, okay, so whenever we are finding magnitude we will write like this, mod, okay, so this is under root 9 plus 81 plus 36, okay, so this is under root 126, okay. Now what we have to do, we have to find this n cap, that is gradient of phi upon its magnitude, okay, so the answer of gradient is what, 3i plus 9j plus 6k, okay, and its magnitude answer is what, under root 126. So in this way we can find a unit vector normal to the surface, right? Now let's solve one more example. If r is given, that is xi plus yj plus zk, then we have to show that gradient of log r is 1 upon r cap, okay, r cap is unit vector. Now r cap is unit vector means what, it is r vector r upon its magnitude, this is r cap, okay, and we have to show this. Now r bar is given, that is xi plus yj plus zk, okay, so if I want to write its magnitude, so magnitude can be written in this form also, it can be written like this also, so r is what, under root x square plus y square plus z square, okay, just square on both the sides, so you will get r square is equal to x square plus y square plus z square. Now what we will do, we will just differentiate this equation number 1 with respect to x, y and z separately, okay. So differentiate 1 with respect to x. So what you will get from here, 2r del r by del x is equal to 2x, okay. So from here we will get del r by del x as x upon r. Now if you will differentiate this equation 1 with respect to y, so what you will get, 2r del r by del y is equals to 2y, okay. So from this you will get del r by del y as y upon r, okay, and then if you will differentiate this equation number 1 with respect to z, so you will get 2r del r by del z is equal to 2z, and del r by del z will be z upon r, okay. Now we will use this result to solve this question, okay. Now we have to find del of log r, okay, so we have to find this del of log r. Del means gradient, okay, del log r means gradient of log r, gradient of log r. Now the formula is what, suppose this is phi, so this is what, del phi by del xi, okay. Now here phi is log r like this, okay, so plus del phi by del yj plus del phi by del z, okay, this is the formula. Now let's find the derivative with respect to x. So derivative of log r is what? 1 upon r, and derivative of r with respect to x is what? Del r by del x I. Okay, now again with respect to y, so it is 1 upon r del r by del y j. Okay, and 1 upon r del r by del z k. This is the derivative with respect to x, y and z. Now we know the answer of del r by del x, del r by del y and del r by del z. We have already solved it. Okay. Del r by del x is x upon r, del r by del y is y upon r and del r by del z is z upon r. So just substitute the answer. So here we have x upon r I plus y upon r j plus z upon r k. Okay, we'll take this 1 upon r outside. Okay, so what you will get? Xi plus yj plus zk upon r. Now this is vector r. Okay, so this is 1 upon r, this is vector r upon its magnitude. Now vector upon its magnitude, so this we can write it as r cap. So r cap upon r. So del of log r is what? R cap upon r. Okay, r cap upon r. This we want to prove, and this we have already proved, right? So I hope you have understood throughout the session. Thank you for watching.